In this video, I would like to do just a quick tour of a statistical calculator that I have created for you, my students. This calculator will take summary statistics and do inference, use them to do inference. So for example, on the first page here, we have a one sample proportion. If you have a sample and you've counted the number of successes in the sample and you have the sample size, it'll create the sample proportion. It'll also give you confidence intervals and hypothesis testing. So let me just show you a little bit about this statistical calculator, this inference calculator. You can see the dark blue cells. Those are the cells where it's going to need some information. So for example, you have a problem where you have the number of successes and the sample size. You're going to have to put those in to do one sample proportion inference. If you want to do a confidence interval, you're going to have to provide a confidence level. It could be, say, a 99% confidence level. If you want a 95%, you can change that to 0.95. It'll give you the critical number. It gives you the estimated standard error. It gives you the margin of error. It will also give you the lower and upper limits. For hypothesis testing, you put the number, the p sub 0, the number that is given by the null hypothesis in the blue, and then the rest of it is calculated for you. You get the standard error, you get the test statistic, you'll get the p-value, though it will give you all three, the left-tailed, right-tailed, or two-tailed p-values, and you have to decide which is the appropriate one for your test. So I have provided you with one sample statistics. You can do two samples. So for two proportions, you would need the number of successes and the sample size for each of the two samples. It'll give you the difference. It'll give you, you can also do a confidence interval for the difference between the two hypotheses, the two population proportions, or you can test the difference. We also have the sample mean. One sample mean, you give the mean, the sample standard deviation, the sample mean, the sample standard deviation, and the sample size, and it'll compute, say, if you have that confidence level, it'll give you the sample size. It'll even compute the degrees of freedom for you and the critical number, and you get your confidence interval. Or for a hypothesis test, you need to give the mean that is hypothesized by the null hypothesis. For two sample means, you'll need the sample mean and the sample standard deviation and the sample size for each of the two samples. It'll calculate the difference. For the degrees of freedom, most statistical calculators use a complicated complicated formula for the degrees of freedom for a difference of population means. Most textbooks will say just take the lower of the 2 degrees of freedom from the individual samples. So in this case, we have samples of size 5 in both samples, and so the degrees of freedom should be 4, but according to the textbook. But that's masking a more complicated formula that they don't want you to have to worry about. And so this is the real degrees of freedom that you would use. And so since we're using technology, I decided to calculate that for you. So